Welcome back, everyone. I'm Jordan Giesige, and this is The Limiting Factor. Elon Musk wants to build 1 terawatt of compute, which of course poses 2 separate challenges. The first is manufacturing the computer chips necessary to provide the compute, and the second is generating the power needed to run the computer chips. Many people are pointing to chips as the primary bottleneck. So in this video, we're going to take a look at how Elon might source the chips he needs to begin tackling his goal of 1 terawatt of compute. I say begin tackling because I'll be focusing on the next 5 years. That's because the time between now and 2030 is critical for establishing a long-term sourcing strategy for computer chips. Along the way, I'll show that although chips will be a bottleneck for scaling to 1 terawatt of compute, there may be a better way of looking at the scaling challenge. Before we begin, a special thanks to my Patreon supporters, YouTube members, and Twitter subscribers, as well as Rebellionaire.com. They specialize in helping investors manage concentrated positions. Rebellionaire can help with covered calls, risk management, and creating a money master plan from your financial first principles. The reason many people are pointing to computer chips as the primary bottleneck for 1 terawatt of compute is that computer chips are difficult to manufacture, particularly the high-performance chips used for AI workloads. That's because manufacturing those chips requires extreme precision and constantly pushing the bleeding edge of physics, which only a handful of companies are capable of. That difficulty is reflected in the cost and profit margins of the GPUs those chips go into. GPUs make up about 50% of the cost of running an AI data center. Most of those GPUs are from one manufacturer, NVIDIA, and they net roughly a 50% profit margin because the competition is thin. There are, of course, other manufacturers of high-end GPUs for AI, but none can currently match NVIDIA's scale and their product ecosystem. For comparison, manufacturing energy products like solar panels for power generation is relatively simple, and the machines and skills to do so are widespread. As a result, the net profit margin on solar panels is an order of magnitude smaller than for NVIDIA GPUs, at around 5% compared to the aforementioned 50%. And taking a broader view, power is only around 10% of the cost of running a high-end AI data center. That's because power is abundant relative to GPUs. And if there's a shortage, most tech companies could just build more power generation themselves. So, to a certain extent, power is a problem that can be solved by throwing money at it. The same isn't true for GPUs, because supply is more restricted. So if Elon wants to build anywhere near 1 terawatt of AI compute this side of 2040 before he retires or moves to Mars, he needs near unlimited access to computer chips. To achieve that, as Elon has done in the past for critical components like batteries, he'll use a multi-pronged sourcing strategy. First, he'll buy as many chips from NVIDIA as possible for the training data centers of xAI and Tesla. By training data centers, I mean the data centers that crunch huge amounts of data with huge amounts of compute to train the AI models or digital brains that are then used in products like xAI's Grok and Tesla's self-driving feature. Second, Elon is renting cloud compute for inference from companies like Oracle. By cloud inference compute, I mean the compute necessary to serve public demand for the Grok AI chatbot once the AI model is trained. Third, for the next few years, Tesla will use TSMC to manufacture the AI5 chip that will be used to run the self-driving feature in Tesla's vehicles. That chip will be 8 times more powerful in terms of raw compute than the hardware 4 chip currently used in Tesla's vehicles and is expected to start production in the next year or so. Fourth, around 2028, Tesla is expected to release the AI-6 chip in partnership with Samsung as part of a $16.5 billion deal for manufacturing in Texas. The key feature of the AI-6 chip is that it's expected to achieve convergence for Tesla's chip supply. What do I mean by convergence? While it's possible to use almost any AI chip for both training or inference compute, there are often power, bandwidth, and other design factors that mean certain chips are more practical for certain use cases. For example, you wouldn't put a 2,000-watt GPU in a robot because it would drain the battery in an hour. The AI-6 chip will get around that by being more modular, what Elon is referring to as convergence. Convergence means Tesla will use the same chip in everything, but vary the number of chips for the specific use case, meaning that AI-6 is intended to be used for Tesla vehicles, the Optimus robot, and data centers. Interestingly, although the AI-6 chip will be used in vehicles as the inference compute for self-driving, it could also have a trick up its sleeve. When the self-driving vehicles aren't in use driving people around, the AI-6 chips in those vehicles could serve as distributed cloud compute. That is, rather than sending a Grok query to a rented Oracle data center, xAI could send it to an idle Cybercab vehicle to process the query on the AI-6 chip. So if AI-6 and later chips are able to achieve convergence, does that mean Tesla and xAI will only use in-house chips in the late 2020s and beyond? The first and preferred option will likely be to use chips from Samsung, but they'll also still use GPUs from NVIDIA and rent compute from companies like Oracle to keep that compute on tap. And of course, the AI-6 chip isn't coming until later in the decade. In the meantime, Tesla will also be producing their AI-5 and Dojo 2 chips from TSMC. On that note, why did Elon cancel the much-hyped Dojo project? To understand that, we first need to understand why Elon started the project in the first place. Dojo was originally announced in April of 2019, so over 6 years ago, which means the project would have likely been started a year or two before that. The reason why Tesla started the Dojo project was to ensure that Tesla had vast amounts of training compute to process video data for their self-driving feature. At the time, that was understandable, because training compute was the primary kind of compute needed to get the AI industry off the ground. Hardware was much more expensive per unit of compute, and NVIDIA was only on the second version of their AI-specialized GPUs. That is, the AI chip industry was still finding its legs, and Tesla had huge ambitions. So Dojo, at its core, was a way for Tesla to ensure that no matter what happened, in the future, Tesla would have access to all the compute they needed. It was ultimately a pragmatic decision. But, of course, that's not a vision that inspires engineers to come work for you, which is often the point of Elon's technical presentations. So the Dojo presentations dazzled with the promise of next-generation training compute, and people mostly overlooked the more strategic purpose as a backup plan. With that said, anyone that did serious analysis on Dojo was aware that it would take years to not only get it off the ground, but to become competitive with NVIDIA's rapidly improving chips. That includes Elon himself, who said on several occasions that NVIDIA was tough to beat and that Dojo's future wasn't 100% certain. So now that Dojo's been canceled, does that mean we can consider it a failure? Yes and no. Let's take a look. Elon stated in July of 2024 that by the end of the year, Tesla would have at least one Dojo data center up and running, with a total processing power equivalent to around 8,000 H100 GPUs. He also stated that Tesla had installed 40,000 hardware for inference GPUs from their vehicles to support around 90,000 NVIDIA H100 GPUs for their training compute. Yes, it's likely those 40,000 hardware for GPUs weren't being used for training foundational AI models, and were instead being used for tasks related to refining those AI models, but it became clear the vehicle GPUs are capable of performing other tasks, and at a massive scale. In my view, this was foreshadowing. Then, in Tesla's Q2 2025 earnings call, Elon said that Tesla expected to have 100,000 H100s worth of Dojo 2 compute installed sometime next year. That means even though Elon canceled the Dojo project, it reached the point where it's fully deployable. So why not continue to deploy it at scale to make the most of their investment and reduce their reliance on chips from NVIDIA? Notably, Elon also said in that earnings call that AI5, which will replace Hardware 4 as the inference GPUs in the vehicles, is really spectacular. He also said that with Dojo 3 and AI6, they wanted to try to find convergence. At the time, it wasn't clear what he meant and the implications, but it quickly became clear just 2 weeks later, when Elon made the announcement that Dojo was an evolutionary dead end, but that AI6 will live on as Dojo 3 when they start mounting several of those chips to a board, which would allow them to be used in data centers. What did he mean by evolutionary dead end? Last year, Elon said that for Tesla, training compute is relatively small compared to inference compute. That's because AI models are trained in one data center and then deployed by way of many data centers or millions of devices. In the case of Tesla, that's the vehicle fleet, which is always growing. So ultimately, only about 5% of the compute that Tesla will need will be training compute, and the remaining 95% will be inference compute used in vehicles. That means it makes much more sense to use one chip for all use cases that, as Elon put it, is excellent for inference and at least pretty good for training. So why spend billions of dollars on a beyond next-generation specialized training architecture like Dojo if training is shrinking as a proportion of total compute? It's much more pragmatic and cost-effective to make an excellent inference chip that can also be used for training by throwing a dozen or so on a board with high bandwidth communication. For reference, NVIDIA's newest product, the GB200, only has 2 GPUs on each board. That means Tesla could be aiming to put more compute power on each board. Even if each of the individual AI6 chips is less efficient and less powerful than the NVIDIA chips for training, the higher overall power on each board would make building and wiring the data center much easier. That's because for the same amount of compute power, there would be fewer boards to rack, along with the expensive and complicated wiring that goes along with them. Additionally, as I said earlier, NVIDIA's net profit margin is around 50%, which means that Tesla could save roughly that much by building their own GPUs, servers, and data centers with chips from Samsung. If that's the case, internally, Tesla's still competing with NVIDIA because they still need to be the masters of their own destiny for AI compute. It's just too strategically important to be completely reliant on NVIDIA. The same is true for xAI. So if the next generation AI6 chip does achieve convergence and are produced in volume, they'll also likely be sold to xAI. I think this is why Elon said that the $16.5 billion deal with Samsung is just the bare minimum, and the actual number is likely to be several times higher. So was Dojo a failure? If you look at it rigidly, yes, it was a technical dead end. But that's because training compute ended up being less important than it seemed when the Dojo project was started. However, the core purpose of Dojo was strategic stability, and Dojo 3 will live on as AI6. Furthermore, AI6 will achieve something that's potentially more important. convergence into one chip to rule them all. The last point to cover is, why did Tesla choose Samsung to partner with for chip production instead of TSMC? Much like NVIDIA has a near monopoly on GPUs for AI compute, tech companies are beating down the door of TSMC to make the chips for those GPUs because they're the world's most advanced chip manufacturer. TSMC works hand in hand with their customers, and they of course put the most effort and use their best teams for working with their biggest customers. So if Tesla worked with TSMC, they likely wouldn't be a priority customer. Samsung, on the other hand, has been struggling to drum up business for their new chip fabrication plant in Texas. They tend to be a less efficient manufacturer than TSMC, and they struggle to make a profit. By partnering with Samsung, it will give Tesla plenty of headroom to rapidly scale their chip supply with the second best chip manufacturer in the world. And, more importantly, Tesla will become a top priority for Samsung, who needs the business, and that means a stronger partnership. For example, Samsung has agreed to allow Tesla to assist in maximizing manufacturing efficiency, and Elon will be personally walking the line to accelerate the pace of progress. So, both Samsung and Tesla have a lot to offer each other. And if Samsung can deliver and become a key part of Elon's plan for 1 terawatt of compute, the partnership could eventually be worth trillions of dollars rather than billions. It would also mean that for the most part, Elon will be able to outsource the problem of chip manufacturing. In summary, let's revisit the point that I made in the introduction, which is that it may be incorrect or an overly narrow way of looking at things to assume that chips are going to be the main bottleneck for 1 terawatt of compute. Much like a vehicle is made of tens of thousands of parts, and it only takes one of those parts to be missing to stop the production line, the same will be true for AI data centers. It's not simply a matter of pulling together the chips and power generation, it's everything in between. The concrete and steel for the buildings, the copper and the millions of miles of wire that will be needed for networking and electricity, the massive cooling systems, as well as the circuit boards, LEDs, transistors, inverters, and switches. But even if we just focus on the chips and power generation, those are two very different scaling challenges that are each difficult in their own way. Chips are small and require extremely high precision, whereas power generation, regardless of type, will be needed at gargantuan scale to power the global AI surge. For example, the chips in an NVIDIA GPU probably weigh about 20 grams each. For 1 million GPUs that contain 2 chips each, that's about 40 tons of chips. 40 tons is the weight of just one Megapack XL. And to power those 1 million GPUs, depending on the local infrastructure, it could require about 1,000 megapacks, which is about 1,000 truckloads or 40,000 tons of battery packs. That, of course, doesn't even include generation equipment like gas or solar, which also weigh thousands of tons. That is, much like Tesla constantly faces a game of whack-a-mole with the supply chain for their vehicles, the same will be true for scaling to 1 terawatt of compute. So I'm not overly concerned with predicting what the exact bottleneck will be, because I expect it will vary over time, and that those bottlenecks will eventually be solved. However, personally, I'm going to be paying the most attention to the power generation side of things because I think it will be the most interesting aspect of scaling to 1 terawatt of compute. Why? As I said a moment ago, Elon can mostly outsource the chip problem to companies that specialize in chip production. It'll happen behind closed doors with people in bunny suits, and for the foreseeable future, it looks like Elon's companies will have an increasingly solid supply of computer chips and compute in general from a variety of sources. That's as opposed to the power generation problem for 1 terawatt of compute, which is going to be much more visible because it will require millions of tons of equipment and millions of acres of land to put it on. And, of course, Elon's companies will all be deeply involved in solving the power generation problem because it's in their wheelhouse: solar, batteries, and other manufacturing. So, in the next video of the series, we'll start taking a look at the power generation side of 1 terawatt of compute. If you enjoyed this video, please consider supporting the channel by using the links in the description. Also, consider following me on X. I often use X as a testbed for sharing ideas, and X subscribers, like my Patreon supporters, generally get access to my videos a week early. On that note, a special thanks to my YouTube members, X subscribers, and all the other patrons listed in the credits. I appreciate all of your support, and thanks for tuning in.